afternoon.
Good afternoon. Thank you. All right, so my name's Stephen Magill. I've been doing academic research in software analysis, security, and programming languages for more than 15 years. First as part of my PhD work at Carnegie Mellon, and then at other universities and industry research labs. Over the last few years, I've been getting more and more interested in the practice of software. So how open source development practices, how those work, how enterprises approach software development, and really how to best contribute to these communities by improving tools and practices.
Thank you, Dr. Magill. My name is Gene Kim. I've been studying high-performing technology organizations since 1999. That was a journey that started back when I was the technical founder and CTO of a company called Tripwire in the information security space. One of the most fun things I've had the opportunity to work on is the State of DevOps report, and that was with Dr. Nicole Forsgren and Jez Humble, which resulted in the Accelerate book. And so I think that was so fun because it was the largest cross-population study where we really got to study 30,000 respondents and understand what are the best ways to measure technology performance and what are the specific behaviors that lead to high performance. My area of passion these days is really studying how large, complex organizations are adopting DevOps principles and patterns. So I run the DevOps Enterprise Summit, and I have a book coming out in a week and a half called The Unicorn Project. Maybe just to set the stage for this presentation. We all know that open source software is everywhere. Nat Friedman yesterday said 99% of new software projects include open source. That's great. And so the question then becomes, how do the teams that work on these components, in terms of their update behavior, security, and testing, suddenly all of their behaviors and practices affect us, right? So yesterday, Nat Friedman also said, you are now inviting thousands of developers into your code. And when Steve and I heard that, I think that was kind of that can be interpreted in many ways. And
you're inviting them in. Are they going to be good house guests, or are they going to trash the place? Right?
Exactly right. So that will now impact the quality of the software that you ship. So will they help or hurt? And so really the question becomes, what practices correspond to good security outcomes and therefore good security for the things that you're working on? So just in terms of brief background, I had mentioned the State of DevOps report. This is what's been so great about that is that's the longest running, largest study in terms of what are the behaviors that cause great performance. And in that research, what we found is there was this 4-tuple, maybe 3-tuple of metrics: deployment frequency, deployment lead time, change success rate, and mean time to restore. We found that all those metrics go up and down together, right? And those predict not just this thing that we call IT performance, but also organizational performance. And there's all these behaviors that make those metrics go up and down. And so for the longest time, I've wanted to understand how do we take those learnings and apply them to how software projects are worked on. And so on the next slide, oh yes. So the specific, can we go back one slide, please? So specific questions would be, what are the structures and practices that you in the source code repos that lead to exemplary outcomes that might map to the metrics that we studied in the State of DevOps report? And will we find those same behaviors in enterprise projects as well? So a couple of years ago, the folks at Sonatype approached me and they came up with this amazing idea. They said there might be an opportunity to actually study the Maven Central ecosystem. For those of you who don't know, Maven is to Java as Ruby Gems is to Ruby, PyPy is to Python, and NPM is to JavaScript. And potentially, in the cards was the ability to actually look at, over decades of what was being downloaded in Maven Central, and specifically what is happening inside of the project, including updates. And so this was just such a delightful thing for me because as a can we go back one slide? Sorry. Oh, right, that's right. You're driving. Yeah. I'm going to put this down. So as someone who spends almost all my time inside of Clojure, this is so exciting because Clojure is a beneficiary of the Java and Maven ecosystem. And so it was with incredible glee and delight that I jumped in and I turned to my friend, Dr. Magill.
And I'm more of a Haskell programmer, which is sort of down on the far right of this slide. But Scala as a typed functional language in the Java ecosystem is also close to my heart. And so getting to look at this broad ecosystem that really it's not even about a single language. It's about this collection of languages and tools and frameworks and in particular, a ton of open source that we all benefit from.
Absolutely. So the words I would use is gratitude and enthusiasm. And so on the next slide is what really came out of it. So we spent over a year working on the state of the software supply chain. And so Dr. Magill was the lead investigator, and we were supported by an amazing team at Sonatype: Bruce Mayhew, Ghazi Mahmood, Kevin Witten, Derek Weeks, Matt Howard, and I forgot to mention Brian Fox, one of the inventors of Maven, the longest-lived repository across all of the language ecosystem. So this was an honor beyond words. Stephen, tell us about some of the hypotheses.
Yeah. So we came into the work with a number of hypotheses that we wanted to investigate. The first one was whether projects that release frequently have better outcomes. So really, the open source version of this effect that we see on the enterprise side when we look at the effect that DevOps has had on enterprise outcomes and practices. We also wanted to look at whether projects that update more frequently are generally more secure, and whether projects with fewer dependencies stay more up to date, right? So there's a number of intuitive correlations that we expected to find in the data, and so we wanted to walk through and see whether we actually saw statistical support for these hypotheses. And then finally, hypothesis number 4, which we'll get to at the end, is the effect of popularity, whether popularity is a good proxy for some of these quality outcomes that we all care about. But before I go further into the hypotheses and the evidence that we found for or against these various hypotheses, I want to talk about the data set and what data set we pulled together, what's involved, and the sort of attributes that we focused on. So first of all, as Gene mentioned, we started with the Maven Central data. Maven Central, as of a couple of days ago, I updated these statistics on the slide, contains over 310,000 Java components. Those components are released at multiple versions, of course, and so if you look across the history, there's 4.2 million artifacts, so individual jars that have been uploaded to Maven Central and are available for use. And then almost 7,000 of those have corresponding GitHub projects, right? So we can look not just at the Maven Central data, but at the GitHub manifestation of that and the metadata and the contributor profiles and everything that's associated with those open source projects and their development on GitHub. And then, of course, we've heard a lot about security, both at this morning's keynote and then in other talks throughout the conference. And that's a central concern here as well, right? So statistics show that almost 9% of these components are vulnerable. And so, what is it about the vulnerable components, the non-vulnerable components? Which components are best at responding to security incidents and remediating vulnerabilities? And so we wanted to look at that, not just at the individual project level, but taking into account the dependency structure, right? So here is the dependency graph for a particular Java component, and you can see, it's quite deep, right? So this gets back to the comment from this morning that you have to consider your dependencies and their dependencies and the dependencies of the dependencies, and it goes on and on, right? So what happens when one of these updates, right? It kicks off a whole chain of things, right? The projects that use that dependency now have to update their version, and that update has to propagate. And so we looked a lot at that propagation behavior. And so to do this, we started, as I said, from the Maven Central data, but then we applied a number of filters to focus down on a set of data where we really had all the attributes and associated metrics that we cared about so that we could really do an in-depth analysis. And so the first thing we did is we looked at just recent projects. So we looked over the last 5 years, because development practices, tools, development culture changes over time, and we wanted what we found to be relevant to developers today. Then we looked at whether the component was connected into this open source supply chain, right? There's a lot of components that are just isolated projects. Maybe it's a personal project. Maybe it never took off. But if no one in the open source community is using it, and it's not using any open source libraries itself, then it's really not part of this supply chain. So we filtered out based on that. We filtered on our ability to recognize versions. So Maven Central, the Maven tool has a particular standard for versioning. So we just looked at sort of well-formed version components. And then basically all of those attributes for the dependencies as well. Because like I said, we want to focus a lot on the dependency behavior and how projects update dependencies. And then finally, updates are going to be critical, like how components respond to updates. And so having had a dependency be updated is important. And so applying all of those filters, we get down to just over 13% of the population, which is a small subset, but includes all the popular open source projects that you're familiar with, right? It includes all of the projects that are widely used that are well connected in this open source dependency graph. All right, so the attributes we looked at are popularity, and we'll talk in more detail about each of these in the next couple of slides, but I'll just go through them. Popularity, release frequency, then a number of metrics that we get by connecting to that GitHub data that I talked about, right? So some of these projects have associated GitHub repos, and so if we look at the GitHub activity, we can see development activity, we can see the size of the development team, whether CI is being used by pulling the repo and looking for CI markers. And then there's a few other attributes, foundation support, and then some security and update-oriented attributes that require their own sort of slide deck to go into, and we will go into them. But first, I want to focus on just how we collected these popularity and activity metrics. So, Gene?
Perfect, yeah. So the first set of attributes, as opposed to the outcomes, I'll go through each one. So the first one is like popularity, right? And so this is a measure of how often is this component being used, how often is it being downloaded. So the specific measurements are how many times is it being downloaded from Maven Central, number of stars and forks. So the library's I/O data set was phenomenal, so we actually used that data set, which actually provides a number of forks and stars for various GitHub repos. So shout out to the great people behind that project. And then we actually, is that to say CI? And then we were able to get access from the Nexus IQ server. So these are the specific projects inside of Sonatype customers, enterprise projects, so we can actually see what components they were using, anonymized, of course. The second set of data that we gathered was around commit activity. And so here we used the phenomenal tools from the Chaos project, including Percival. And so one of the things that we gathered was the commits per month. So for every, we use Percival to go to GitHub, which I would actually download the entire Git repo and then crack that open. And so we could actually see how many commits were being made per month. And then we actually measured how many unique developers were there. So this is kind of a proxy for how many active developers are there on that specific project. And then we also looked for, and so the way we did is we used Percival, we used JQ to open that data, and then we used Clojure to basically do a 3-day scan for those 14,000 repositories. Yeah. And then the other thing that we did is looked for presence of continuous integration servers. So we looked for, we grabbed the HTML from the front page of the repository and looked for markers of CI configuration files. What was Travis, Circle CI, Jenkins, and others.
Yeah. And so actually that's actually the last you'll hear about CI in this talk, because we didn't find a connection between use of CI and some of the other outcomes we were looking for, which was really surprising. And really, I think we'll get to this outcome later, but it's not just about the tools you use, it's about the practices and the culture around those tools. And so, that was one indication of that. And really
one mini surprise right there,
yeah,
right? Is that you would have thought that the presence of CI and automated tests, right, would be, some predictive of something or correlated with something, and that was actually not the case.
Yep. All right. So we also looked at a number of other project-level metrics. So. The first is, and is relevant to here, especially as we heard in the keynote this morning yesterday about support for open source projects and what GitHub's doing there. What sort of support does the project have? Is it foundation supported? Is it commercially supported? Or is it just an independent project? So we identified by hand some number of foundation-supported open source projects, and then created a classifier that we could generalize across the data set and automatically label those repositories based on foundation support. We looked at number of dependencies, which we took as just the maximum, so the high water mark across all versions over this 5-year period of the number of dependencies used by a project. We looked at stale dependencies. So sometimes a project will release an update, and one of its dependencies has a newer version available, but they don't move on to that newer version. And so we mark that as stale. That's one of the factors that we consider in rating projects. And then the release frequency. How frequently does this component release as a marker of development velocity? Mm-hmm. Yeah.
Yes. OK, so hypothesis number 1. Was that projects that release more frequently will have better outcomes. So this is, of course, based on just experience coming out of the State of DevOps report, where we found that deployment frequency went hand in hand with deployment lead time. And in general, right, the more you release, the better all the other outcome measures are. So this was, we wanted to look at, all right, do projects that output more releases more frequently, would they have better outcomes? Confirmed.
Yeah, so this was validated. Excuse me. Yeah, so on the whole, projects that release more frequently are more popular. We took popularity as the main proxy for a positive open source outcome, right? People contribute to open source because they want their code to have impact. They want to provide capabilities to the rest of the world. And so popularity is really a great measure of how well they're accomplishing that. And so here are the statistics behind this, right? So the projects that release most frequently, so the top 20% of projects, are 5 times more popular on average. This is rated by Maven Central downloads in particular. But the same connection holds with stars and forks. Excuse me. They also, on average, have 79% more developers and have greater foundation support rates, 12% greater.
And that's interesting. By the way, just to back up on the analysis, so so we split the population into those that had the top 20% of release frequency, right, and then compared all the measures that Stephen talked about. And if you could go back one slide, right, so the big surprise here was about, again, the development team size. Right, the question is, do larger teams lead to more frequent releases, or does popularity in active projects attract more developers? Right, and of course, with this sort of analysis, you can't know that, but it does lead to some very interesting questions.
Yeah, so then I want to say more about these last 2 metrics that I mentioned as more complicated, right? So security and update speed. And so here, I want to walk through sort of a progression of updates in a typical open source supply chain. So here we have just some packages labeled A, B, C, D, or A, B, C. And you can view time as marching from left to right. Right? And so we have several versions of each package displayed here. Dependencies, the solid lines represent dependencies. So here, package C is dependent on A and B. And we can see several releases of A, right? It starts at version 2.2, moves on to version 2.3, and then releases version 2.4. That new version of dependency A is eventually picked up when C releases its next version, so at this point, right? And we also have vulnerability information depicted here, right? So these red points are points at which we're assuming a vulnerability is discovered and reported, in this case, to component B. And so there's some period of time where B is vulnerable. And because C depends on B, there's some period of time where C is vulnerable. And so that vulnerable time is interesting, but what's really more relevant and actionable is this remediation time, right? How long does it take from when B patches that vulnerability to the point in time when C adopts that patched version of B? And so we call that remediation time, TTR, and we calculate that for each security relevant update. We also, for each update, whether security relevant or not, capture the update time. So how long, again, does it take C to adopt this updated version of B? Whereas B is the only vulnerable component in this example, there are other components that update, right? So there's an update time for A, and so we can record that update metric for every update to every dependency, whether security relevant or not, and we call that TTU. So you'll see that in the next slides as well. And then this is this notion of stale dependencies that I mentioned earlier, where C here is releasing a new version. There's a more up-to-date version of A available at the time of that release, but C doesn't adopt that. Excuse me. So that really gives us 3 key dependency-oriented metrics: time to remediate, time to update, and stale dependencies. And we get these on a per-update basis, but we can also roll them up to a per-project basis by looking at the median of those collections of metrics.
Yeah, so this is so cool because now we have the time to remediate security vulnerabilities and the time to update any dependencies across the entire population of the 14,000 projects across all of their versions. So the graph here shows on the x-axis is the days to remediate vulnerabilities, and the y is what percent of the population. So this is a cumulative it's a cumulative, what do you call it?
Yeah, a cumulative distribution.
Cumulative distribution, right.
Yeah.
So like at the very right, ideally 100% will have updated or remediated vulnerability. So here's kind of how to read this graph. The median is 180 days. The mean is 326 days. And so just maybe take a pause there. It takes a half year for the average component to remediate a published security vulnerability. And by the time you get to 3.5 years, 95% have updated. So we actually cut off the graph because it goes on forever.
There's a long tail of poor
very
update
long tail.
behavior. Yeah.
So that's a log normal distribution. And so that's a kind of sobering finding. I think this is consistent with some of the statistics we've seen that we were able to validate in this analysis. So one other observation here is, and so on the next slide, right, so it's actually this lower left quadrant that we want to study. These are the potential exemplars who, for whatever reason, right, remediates security patches quickly, right? So that's kind of the population we want to study. So the other thing to note is that the time to remediate metrics are actually pretty sparse, that not every component actually has a CVE published against it. So overlaid onto this, on the green, is the time to update. So if a component has updated, we have, they're going to be in this population, which is a much bigger set. And again, just to read this, the median time for projects to update is 130 days. So I guess it's about a third of a year. Again, it's the same sort of log normal distribution. So that's actually a little bit sobering as well.
Yeah, and interesting. So you can see these distributions match very closely at the population level. But we wondered at the project level, is there also this correlation?
Right.
Yeah. And so here we have time to update and time to remediate, so security relevant and non-security relevant updates graphed, where each point corresponds to a single project. So where does it live in this space of time to update versus time to remediate? And so the line that's depicted there, those are projects that lie on that line, are projects that treat security relevant and non-security relevant updates equally, right? Equally, they respond in the same way to both. And so, going back to the previous slide real quick. So we did find a correlation here. So the correlation coefficient is 0.6. It's maybe not super obvious from the graph, but there is some signal there in terms of those two tracking together. And you can look at it a couple of other ways too. You can say, if we loosen it up a little bit and we say, okay, they don't have to match exactly, for what percentage of the population do we have update behavior and remediation behavior that's similar within 20% of each other? 55% of the population has that property. And so that's like if you think about these fine lines on either side of the thick line, you look at the projects that fall within that, that's a majority of the population.
And maybe just a pause there, if we go back to that slide. So I think the graph depiction is actually maybe a little bit misrepresentative because the dots are so big. But just to reiterate what Steven said, is that most of them fall within that cone, right? That MTTR and MTTU do generally kind of are within that cone.
Yeah, and if you think about what would it mean to not be in that cone, to not have similar update and remediation behavior? That would be being, say, better than average at remediating security vulnerabilities, but worse than average for updates in general, right? So a project like that would be paying a lot of attention to security-relevant updates, but basically ignoring other updates. And we only see 15% of the population falling within that category. So it really is rare to have exemplary security performance without just generally good update performance.
Maybe just to take that to extreme. So there is a population that only applies security patches and never updates, non-security updates, and there's a population that only updates non-security relevant things and always ignores patches. But that is a small population.
They're small. Yeah. All right. Do you want to take this one?
Yeah. So the conclusion here, the interpretation is that projects that update dependencies more frequently are generally more secure. In fact, I think on the next slide, there's actually some more guidance on this. This actually came from Jeremy Long. So he's the author of the famous OWASP dependency check project. And he, one of the things that he said at a security conference that just really struck me was this: the best way to stay secure, meaning and apply security patches, is just to stay up to date. Right? In other words, security patching is a subset of dependency update behavior. He gave a really interesting case. It was the Prime Faces CVE that came out in 2017. So this is a vulnerability in some component. But what's interesting is that even though the vulnerability was published in 2017, the fix was actually pushed out in 2016. So if you had stayed up to date, you would not have been vulnerable to this vulnerability. In fact, the publishing of the vulnerability is actually what then drove the exploit of the vulnerability, and now suddenly you have crypto mining happening on your servers. So again, I think this is a great evidence point that says the best thing that you can do is integrate updating dependencies into your daily work. This should be a part of your regular development activity.
Yeah. Another way to say it is when an update comes out today, you actually don't know whether that's security relevant or not in the future, right? It's not security relevant today, but as this example shows, 2 years from now, it could suddenly become security relevant.
Right. Okay, so hypothesis one was about release frequency that lead to better outcomes. Yes. Hypothesis number 2 was, is there a link between MTTR and MTTU, right? Yes. So hypothesis number 3 is pretty obvious, right? If it's difficult to update dependencies, it's pretty obvious, right, that projects with fewer dependencies will be able to stay up to date more easily, more frequently, whatever, right? If it's a lot of work, then having fewer dependencies will mean less work and better outcomes. Seems pretty obvious. But no, no, it was the exact opposite. It was those components with more dependencies had the better time to update, which is very counterintuitive and very surprising.
So this was so surprising, we dug in deeper. We had to know what was behind this effect, where you have more dependencies and better update behavior. And so we actually found, so this is a plot of development team size versus number of dependencies. And the explanation for this effect...
So on the x-axis, number of dependencies, and the y-axis is the number of developers committing in a given month.
That's right. And so projects with more dependencies also tend to have larger development teams. And if you just look at larger development teams by themselves, that correlates with faster MTTU, better update hygiene, better release frequency, and so forth. So as Gene said, this is a plot of those two against each other, and you can see sort of as dependencies march up, you have to buy more pizza.
Thanks to Derek Weeks for that lovely quantization of team size to number of pizzas for the team.
It's an important metric. Of all the metrics we collected, I think pizza, team pizza
is this
size
interesting? Is this thumbs up? Yeah. Okay, cool. And so specifically, if you go back one slide, maybe just to land the point, larger development teams have 50% faster MTTU and release 2.6 times more frequently. So that's really interesting and in some ways curious. So now there's more questions. Is it that as you grow development size, if you grow the team size, do they all just bring in their own components? Or is it the other way around? Is it the work that it was required by bringing on more dependencies is actually what drives the need for more developers, right? Again, we don't know which way is the causation, but I think this is just a fascinating and tantalizing finding.
Yeah. All right. The last hypothesis that we want to talk about has to do with popularity, and in particular, whether more popular projects will be better about staying up to date. So, if we take update behavior, update hygiene, and thus remediation behavior as important security and project health metrics, are popular projects, exemplary with respect to those attributes. And this is important because I think a lot of people choose primarily based on popularity, right? I need a logging library. I'm going to go see what the most popular logging library is, right? But actually, we did not find evidence for this. And one bit of counter evidence is present in this chart. So this is a graph where the x-axis is release frequency. So at the far left is projects that release very frequently. The far right is very slow release cycles. And popularity is on the y-axis. And this is a log scale. So you can see it goes up, and it's a number of daily downloads on Maven Central. And it goes up into the millions, right? And so what we've drawn here with this box is a slice of this population that is quite popular with respect to Maven Central downloads. I mean, the bottom there is 10. You're getting at least 10 Maven Central downloads per day if you're in that box. But there's a lot of poor performing projects from an update hygiene perspective in there. So I'll say more about the different colors in a minute, but red is bad, okay? So the fact that there are so many red dots, in this popular box shows that there certainly are popular projects that are not good with respect to update hygiene. So that's the first point here. There's plenty of components with poor MTTU that are popular. But maybe those are just outliers. There's always some outliers, right? But you can look at it a couple of other ways and see that actually, if you look for a correlation between popularity and MTTU, maybe there's some weak signal there, but no. There's nothing statistically significant in terms of correlation there. And even if you try and slice up the data and you say, well, let's just focus on like the top 10% by popularity, right? Those are really standouts. Like everyone's using those. Like surely there's some difference between them and the rest of the population with respect to update behavior. But no.
And so this is like one of those categories of findings that you just really try to find, right? You're going to do whatever it takes to like get that signal to come out. And we spent weeks on this. And no matter how we cut the data, no matter how we applied the clustering analysis, we couldn't get it to show up. And I think the reason why it was so troubling to me is that whenever I'm working on a project and I have to pick a new something, right, logging framework or whatever, like here's my heuristic. I go to GitHub and I look for how many stars they have, right? And if it's thousands of people that are using it, I just assume that's a good project to use. And so apparently this is actually not a very good heuristic at all, right? Popularity, as measured by stars, forks, or download count, is not. It does not correlate with any measurable good outcome that we identified.
I think Gene ran back and started going through all the libraries he's using right after this. So as Gene said, the number of stars and forks is not an effective heuristic for selecting which components to use, at least if security is important to you, which
right.
is, right?
Okay, that's fair. If security is not important to you, then go ahead and use stars and forks as a good heuristic. But if you care about security, it is decisively not.
So I'd say if there's one takeaway from today, like take a mental screenshot of this slide, right? Consider factors other than popularity in your choices. All right, so then we wanted to look more at sort of the high-performing projects, the low-performing projects, and really see like what factors bind them together, what behaviors do they have in common, really like what behavioral clusters can we identify in this data. And so one interesting thing, so we took the exemplars from an update performance perspective, so the top 20% according to update behaviors, and looked at them more closely. And one thing I find really interesting here is we found roughly equal clusters where one has small development teams. So this is the small exemplars up at the upper left. And they have really exemplary update performance, and they maintain that with very small development teams.
The mean is 1.6 developers, active committers per month.
Yeah. So you don't need a huge team to stay up to date with dependencies, right? It just takes focus and attention to that being a key development concern. We also certainly saw large team exemplars, and really this is, if you look at the open source foundation supported projects, the Apache Foundation, Linux Foundation, those sorts of things, the bedrock of the open source community, these large projects that are an important part of so much infrastructure, a lot of those show up in this large exemplar category at the upper right. And they have, of course, exemplary MTTU. They're also very likely to be foundation supported, as I said, and they're on average 11 times more popular than an average project from the rest of the population.
Yeah, and by the way, this was like one of the sort of like kind of really surprising things for me was just when you do this kind of clustering, the thing that pops out is that you have this, in my mind, I sort of kind of called it the open source industrial complex. These large projects that have a small army of developers working on it, as measured by 10 plus unique developers on it. It's clearly part of their day job to work on this. The fact that those exist, confirmed. What was so interesting is that being an exemplar is not in the domain of these commercially supported or foundationally supported projects. So in hindsight, of course, being an exemplar doesn't depend on the size of the team, right? It's about the values of the team, right? It's about their practical practices, what do they hold important. Right. And for the same reason, that's why probably the presence of a CI configuration file is not a marker of performance. It's not that you're using CI, it's about how well you're using it. And so that's really about values, philosophy, and so forth.
And as further evidence of the importance of values and philosophy, we have this cluster in the bottom middle here, features first, right? And this was a group of projects that actually releases updates frequently, right? So they're pushing out new code, they're tagging versions and cutting new releases all the time. So they have the bandwidth to stay very up to date. But they're not, right? They're ignoring the dependencies and sort of what's happening there, and just focusing on features and changes to their code itself, right? And so that's an example of, it's not just about the practices, it's what you hold as important as you're doing the development practice, right?
Yep.
And so then there's the laggards cluster that I mentioned. Those are the red ones. So, I said red is bad. That's the bottom 20% with respect to update behavior. And then there's this interesting cautious cluster that actually manages to stay within a couple of versions of the latest. But they're, for whatever reason, not willing to sort of be on that bleeding edge. They want the community to vet it a little bit before they move forward. But they do pay attention to updates to their dependencies and eventually adopt them.
Right, and this, to me, that says that there's some disciplined approach. There's some sort of target band they want to be in terms of being up to date. Maybe not the latest, but close to latest.
Yeah.
So whenever you do these clusters, right, often you're kind of detecting differences, in attributes of groups. And then usually what you'd like to do then is really understand the psychographics of why do they act that way. So imagine if you have n attributes, if you plot that in n space, what clustering does is kind of minimizes the distance between those points, right? And then you can now label them. So one of the things that we had an opportunity to do, and we were able to do this at the last minute, thanks to the amazing team at Sonatype, is we were able to put out a survey where the goal was to actually try to uncover some of these psychographics or at least philosophical decisions of these groups. And so the outcome measures that we asked was on a scale of 1 to 7, how painful is updating dependencies? And how painful, on a scale of 1 to 7, how painful is updating vulnerable components? And so let's focus on that. So there's this cluster that they said they were 1/3 as likely to consider updating dependencies painful, and they were about 1/3 less likely to say that updating vulnerable components are painful. So this group, when compared to the others, they were 10 times more likely to schedule updating dependencies as a part of their daily work. In other words, they're making updating dependencies a part of what they do, whether it's every day or every week. They are 6 times more likely to strive to use the latest version or n minus whatever, right? I don't want to be on latest, I want to be on n minus 1 or something, right? Whatever that band is, that's one of their desires. They're 11 times more likely to have some sort of process before adding a new dependency to their project. In other words, instead of adding things willy-nilly or on a whim, they go through some process, evaluate, approve, standardize, et cetera. 11 times more likely. They're 10 times more likely to have a process to remove problematic dependencies. And they're 12 times more likely to have some sort of automated tool to manage, track the compliance towards those policies.
Yeah. And so more on those survey results and more detail on everything that we discussed is in the actual report. So go download it. If you'd like to receive a copy of the report, actually my email address is there at the bottom. If you just send an email right now, my out-of-office auto response is on, and we'll reply with a link directly to the report. So easy way to go get the report and dig down deeper and see all the other things that we found.
And to summarize, I think this was such a rewarding and interesting project because I think this is the first time that we've been able to actually start to see the behaviors that we suspect existed, and it really illuminates some surprising insights. So again, thanks for the Sonatype team for giving us access to the data and assisting this project to the degree that they did.
So we had so much fun with year 1 of this. We're already talking about year 2, and the additional analysis, additional research we'd like to fold into the second version of this study. And so some of the things that we'd like to focus on are this idea of breaking changes, right? Like we just looked at updates in general, but are some updates easier to adopt than others, and could that underlie some of the behavior that we see? Looking at transitive dependencies, so deeper into the dependency tree, and identifying some of the leading indicators, right? Can we get beyond correlation and start talking about causal factors that underlie some of these behaviors?
Yeah, I want to go into the breaking changes one. There's this amazing paper that was written by a set of amazing, brilliant Brazilian researchers. They monitored 400 Java libraries for 116 days, and in that period, they detected 282 breaking changes. And so this should be jaw-dropping, right? That means like, if you wait long enough, you will take a breaking change in Java. And so this is frightening, and I think it resonates with our common experience on the next slide, which is that the reason why we don't patch or don't update our components is that every time we do, everything breaks, right? And so one of our goals is, one of the help that we're looking for is there data around Dependabot, that says what happens when that pull request is made? What percentage of them are quickly and easily integrated, and which ones are never integrated because everything blows up when you do? We also think that even the notion of breaking changes, there might be something fundamentally wrong with that, right? In other words, in the Clojure community, they've gone almost 12 years without a breaking change in their standard library, right? And so I think that's part of the functional programming orientation. So is there a marker where we can find libraries that are really good at not breaking on updates? They add, that's okay, but you can't subtract, right? And we're also looking on mechanisms to find pull request lead times and issue resolution times. And thank you to the code.gov team who presented yesterday. I'll be finding you. I love the fact that you've done this. We're hoping to use that next year's study as well.
Yeah, and then if anyone knows of an authoritative list of Foundation-supported open source projects, like I said, we developed a heuristic that matched the data that we looked at by hand very closely and extended it to the rest of the data set. But getting a more accurate read on that, I think, would really benefit the study. And so, if you know of a source for that, please let us know. In terms of takeaways, I think, one thing to focus on is that integrating updates into your daily work is super important. The cultural practices around staying up to date are a big part of making this happen. Yeah.
The second one is it's not enough to clean up your house. You got to help clean up other people's houses. For all the dependencies you take, for you to update their dependencies, right? Put in pull requests, I think is enormously helpful because we know that there's a lot of work to do that. Anything you can do to help helps.
Yeah. And then, as we said, don't make decisions based solely on popularity. It was one of the few things, actually, that had no connection with some of the other metrics that we were looking at.
And then lastly, we're specifically looking for hypotheses that you would like investigated, specifically around why don't people update dependencies more often, and what are the conditions that allow people to update quickly, safely, and painlessly and effectively, right? And those are the things that we need to understand better so that we can enable that across the open source ecosystem.
Yeah. So come find us with your ideas. Let's talk more about what would be interesting to see in terms of analysis of the open source community and supply chain.
Thank you very much.
Thank you.